Hey everybody, happy Wednesday. I've switched up my space a little bit today so you can see a different part of my house. Needed to get off my bed and mix things up. I hope everybody has their windows open again. It's so beautiful outside today. Hope you get a chance to get some fresh air safely at some point today. We are going to get started on an adding and subtracting fractions and mixed numbers lesson. You're going to see this coming up a lot in the future packets, so I wanted to make sure we had a good review before we got to do those problems. So I'm going to share my screen and we can get started. All right, we're going to get started with a spiral review as we always do. Go ahead and take some time to read through these three questions. Once you have an understanding of what you're doing, pause the video, take as much time as you need, and then restart once you have solved those problems. All right, the first one was find the difference between 234,452 and 84,987. Find the difference means to subtract. Starting in my ones place, if I have two ones, I don't have enough to take 7 away. I'm going to go next door, decompose this 5 into 4 tens, bring over 10 more ones, so I have a total of 12 ones now. 12 minus 7 is 5. If I have 4 tens, I can't take away 8 tens, going to go next door, decompose 100, so I have 300s now, and 14 tens. 14 minus 8 is 6. I have 300s, I can't take away 9. I'm going to go next door, decompose this 4 thousands into 3. Now I have 1300s minus 900s, which is 400s. Same thing, if I have 3,000s, I can't take away 4, decompose it to 2,000s, make it 2 10,000s. Now I have 13,000s. 13,000s minus 4,000s is 9,000s. Decompose my 100,000 for an answer of 149,465. Give yourself a check if you had that. This one had a lot of decomposing, so if you're unsure, go back through, figure out what I did to decompose, and make sure you understand your mistake before we move on. Number 2 said solve 678 divided by 3. We practiced division in one of the last videos, so we should be ready to solve this one. 3 goes into 6 3 times. 3 times 3 is 6. I had 0 left over. I'm going to bring down that 7. 3 goes into 7. Oh, I'm sorry. 3 goes into 6 2 times, my bad. 2 times 3 is 6. Now 3 goes into 7 again 2 times. 2 times 3 is 6. When I subtract, I have 1 left over. Bring down my 8. 3 goes into 18 6 times, and 6 times 3 is 18. So I have no remainder. Give yourself a check if you had that one correct. Go through and look for your mistake if you made one. And our final problem is Barry solved 34,567 math problems last year. Mr. Cullen solved 2 times as many. How many math problems did Mr. Cullen solve? So I hear 2 times as many, so I know that means I'm going to take my amount and do it 2 times. 34,567 times 2. 7 times 2 is 14. 2 times 6 is 12, plus 1 is 13. 2 times 5 is 10, plus 1 is 11. 2 times 4 is 8, plus 1 is 9. 2 times 3 is 6. So Mr. Cullen solved 69,134 math problems last year. Give yourselves a check if you had it. As always, go through and look for your mistake if you did not. I am going to go back to sharing my screen. And here's today's application problem. We have Marta has 2 meters, 80 centimeters of blue cloth and 3 meters, 87 centimeters of red cloth. What is the total length of both pieces of cloth? Pause your video here and resume as soon as you have had a chance to answer this application problem. All right, so Marta has 2 meters, 80 centimeters of blue cloth. And we're looking for the total, so we're going to add. She has 3 meters, 87 centimeters of red cloth. I'm going to choose to add these separately. I'm going to add my centimeters first, then I'm going to add my meters. When I add my centimeters, I got 167 centimeters, and when I added my meters, I got 5 meters. But when I'm looking at this, 167 centimeters doesn't make sense because I know 100 centimeters equals a meter. So I know I have more than 100 here, so I can pull out a meter. 1 meter would be 100 centimeters, which would mean I'd have 67 centimeters left. So really I have 5 meters plus the 1 meter, I have 6 meters, and then I have 67 centimeters. So we would say that Marta has a total length of 6 meters, 67 centimeters of cloth. We just had to pull out the meters in that centimeters because we had more than enough to make a meter. Give yourself a check if you had it. Go through and find the mistake if you did not. All right, so today's lesson is going to focus on adding and subtracting fractions and mixed numbers. So we're going to practice a whole bunch of different types of problems, which you can refer back to when it's time for exit tickets. Adding fractions and subtracting fractions when they have the same denominator is pretty straightforward. So we're going to look at what happens when we do 2/5 plus 1/5. The size of my pieces is not going to change. I have 2 pieces out of a pizza cut into 5, and then I have another 1 piece out of another pizza cut into the same size 5 slices. So my denominator doesn't change because the size of the pieces and the number of pieces didn't change. But I'm putting those pieces together from the 2 separate pizzas, and I'm getting 3/5. So when we add and subtract fractions, the denominator stays the same because the size and number of the pieces don't change. The amount we have will change, which is why our numerator changes. Let's look at one more adding example that takes it a tiny bit harder. We have 5/7 plus 3/7. It's going to stay sevenths. But I have 8/7. I want you to think or say out loud to yourself, what's wrong with 8/7? It's the correct answer, but is it in the form we want it to be in? This is called an improper fraction. We know 7/7 would be a whole, but we have more than a whole. So we have to use our little number bond to pull out the whole. So I'm going to pull out 7/7 and 1/7. This 7/7 is equivalent to the whole thing. I had 7. There were 7 total pieces, and I have 7 of them. So I have 1 whole and 1/7. In your work today, I do not want to see final answers left as improper fractions. I want them all to be changed to mixed numbers using a number bond strategy. So as you go through your work, if you're struggling with that, come back to this part of the video to help you out. All right, let's look at subtracting. Again, very straightforward when we just have fractions. This is me having 8 total pieces. 8 total pieces, and I have 5 of them. There's a pizza cut into 8 slices. I have 5 left. But then my dad comes and eats 2 more. So I now only have 3/8 left. Again, the denominator does not change because we did not change the size or the amount of pieces that we had. We did change the amount that I have left. So adding and subtracting with just fractions is pretty straightforward. Denominator stays the same, you add or subtract your numerators. We get a little bit more difficult when we get into mixed numbers where we have a whole and a fraction. So let's look at adding those. Oops. We have 5 and 5/8 plus 6 and 4/8. And just like in our application problem, we're going to add each part separately. We're going to add the wholes, then we're going to add the fractions. So when I add the wholes here, 5 plus 6 is 11 wholes. 5/8 plus 4/8, 5/8, 6/8, 7/8, 8/8, 9/8. And I'm going to say, uh-oh here, because I have 9/8, which is more than a whole. So we have 8/8 we can pull out, and then we have 1/8 left. That combines to make 9/8. So now instead of 11 wholes, I have 11 wholes, but I have 1 more whole. So I have 12 wholes and 1/8. So again, when we add mixed numbers, we add the fractions and the wholes separately, and then we need to look, is my fraction bigger than a whole? Can I pull out any extra wholes? Sometimes we won't have to. In this case, our fraction was bigger than a whole, so we needed to do that extra step of pulling out a whole. And last but definitely not least, what I think is the most challenging of all of these types of problems is subtracting mixed numbers. It involves a little bit more effort, and I'm going to look at 2 different examples with you. So the first one is 5 3/5 minus 2 1/5. It's a weird 2. First thing we always want to do when we're subtracting mixed numbers is look and see, if I have to take away 1/5, do I have enough in the fraction over here to do that? And in this case, I do. So this is one that will be pretty easy. I'm going to do the same thing I did with adding. I'm going to subtract my wholes. 5 minus 2 is 3. And because this fraction is bigger than this fraction, all I have to do is subtract 3/5 minus 1/5. So I know that's 2/5. So sometimes we get lucky and we have mixed number subtraction that is very easy to solve, where the first fraction is bigger than the second. But sometimes it gets a little harder. Here I have 8 1/10 minus 8/10. So this time I have a mixed number minus a fraction. And I would do the same thing, subtract the wholes, subtract the fractions. But when I look here, I can't do 1/10 minus 8/10. I don't have enough. So what I'm going to do is borrow from my whole. I'm going to take one of these wholes and I'm going to break it up into tenths. That's going to give me 10 more tenths because 10 tenths is a whole. So I'm only going to have 7 wholes now because I broke one of them up. And I have 10 tenths from the broken up whole and 1 tenth that I already had. So I have 11 tenths. I'm going to go through that one more time. I didn't have enough in this fraction to take away 8 tenths, so I needed to get some more tenths. So what I did was go to the whole and break one of those wholes up into 10 tenths because we know that 10 tenths is a whole. It's the same thing. So now I have 10 tenths from that broken up whole, but I already had 1 tenth, so I have a total of 11 tenths. Now, if I subtract the wholes, it's 7 wholes minus 0 wholes. And it's 11 tenths minus 8 tenths, which is 3 tenths. And one more example for us to look at. We have 6 5/8 minus 2 7/8. So as always, I want to look at my fractions. Do I have enough here to take away this fraction? No, I don't. If I have 5/8, I don't have enough to take away 7/8. So I'm going to go do the same thing I did last time, get some more 8s. So I'm going to take one of my wholes and break it up into 8s. So we know this time that 8/8 is a whole. So now I have 5 wholes, but I have 8/8 plus the 5/8 I already had, which is 9/8, 10/8, 11/8, 12/8, 13/8 minus 2 7/8. Now it's a mixed number subtraction problem I can solve. 5 minus 2 wholes is 3 wholes. 13/8 minus 7/8 is 6/8. Again, I want one more time to explain how we got from 6 5/8 to 5 13/8. I took one of my wholes and broke it up into 8/8. So it's no longer a whole, it's 8/8, but that's the same amount. If I put those 8/8 back together, they would make the whole. So I have 8/8 in one pile and 5/8 in another pile, which gave me 13/8. And then I had 5 pieces that were left as wholes. Then I was able to do 5 minus 2 and 13/8 minus 7/8. Again, as you're working through problems today, if any of this seems confusing for you, I want you to go back to this video, rewatch the parts that go along with the problem you're trying to solve, and take some time to figure it out. You guys have been doing a fabulous job with all of this. So I'm going to share my screen back so we can look at what today's independent practice will look like. Go ahead and pause the video here so that you can take some time to solve these independent practice problems. Resume it when you're finished and take your time. Here are the answers to the independent practice problems from the previous slide. Go ahead and check through your work. As always, your goal should be to get no more than 1 wrong. But if it's okay if you did, go back through, try to find your mistakes, rewatch the examples that I did that go along with the problem that you're doing. And as always, call me or text me to ask me any questions that you still have. I have loved seeing people texting me exit tickets. I'm seeing super organized papers. I'm seeing level 5 work as if we were at school. And all that learning's happening without me being there. So I'm extremely proud of the work you guys are doing. I have 3 exit ticket problems for you all to solve today. And as soon as you're finished with them, check them over, double check your work, make sure you have sentences, make sure it's neat and I can clearly see what you're doing, and then text me a picture so I can reply with your score. Hope you all have a fabulous day, and I will be back Friday with another lesson. Have a good one.